Hello, so we are still in acceleration, but I'm saving paper, so I'm using the same piece of paper. All right, so we're going to first read the problem, get a sense of what's going on in the story. So Earth's gravity accelerates all objects at a certain rate in a vacuum. If an object is dropped, how fast will it be traveling after a certain time of fall? Okay, so now let's take a look at this again. It accelerates all objects at a rate of. So they're telling us right here that the acceleration is 9.81 meters per second squared. So that's good. Acceleration 9.81 meters per second squared. And we know that's true because meters per second squared is a unit of acceleration, and that is something you will want to memorize. If an object is dropped, how fast? We saw that in the last problem. How fast? How fast means velocity. Could mean initial velocity, could mean final velocity, but it said how fast after a certain amount of time. So that tells me we're not talking about where it's starting out or where it's initially at. And then after 6 seconds of fall. Seconds is a measure of time. So time equals 6 seconds. All right, so we know from up here, and probably from your lesson, that acceleration equals a change in velocity over a change in time. Now, normally if we have a final velocity, we have an initial velocity. They say if an object is dropped. Well, we could understand that if an object is dropped, then it's starting out at 0. So I'm going to go ahead and say that. And then for time, they didn't give us a beginning and end time, so this time is the change in time. Okay, now we are looking for velocity, or to be specific, the final velocity. So if we multiply both sides by the change in time, then this is understood to be in the numerator. Change in time in the numerator will cancel with change in time in the denominator, leaving me with change in velocity. And then here we'll have the change in time times acceleration. I'm going to go ahead and switch it around because I think it's prettier that way, if a formula can be considered pretty. All right, so our change in time is 6 seconds. Our acceleration is 9.81 meters per second squared. And so when I'm going to my calculator off to the side here, 6 times 9.81 equals, I get 58.86. What unit? Okay, well, I'm going to go ahead and tell you this is meters per second, and that's because it's supposed to be the change in velocity. But this S is understood to be in the numerator, and so this S could cancel out with one of these S's, leaving me with meters per second, because there's 2 of them here multiplied by each other. Now, as for the whole final initial velocity thing, if change in velocity we could write as final velocity minus initial velocity, and initial velocity is 0. Well, anything minus 0 is just that thing. So I wanted to explain it, though, in terms of final and initial, just because our problems so far have dealt with final and initial. So I didn't want you to think, well, where did it go all of a sudden? But we could have just thought of this as velocity. I guess you could say if your initial velocity is 0, then you could kind of just pretend that your final velocity is just velocity and simplify your problem that way. Okay, don't forget that in the lower right-hand corner, you can click on Settings, and then you can alter the playback speed. I'll see you in the next video.